Hello dear students, myself Ganga Bhosle, your statistics teacher. Today we are going to learn Poisson distribution. In previous lecture we have studied about binomial distribution. This Poisson distribution is a limiting case of binomial distribution which have some conditions. First condition is the number of trials is very large. Number of trials is very large, that is n tends to infinity. Then second condition, the probability of success, which is denoted by P, is very small for each trial, that is P tends to 0. Okay? Now third condition, the mean, that is NP, mean is denoted by NP, is a finite quantity, that is NP which is equal to M is finite. In Poisson distribution we denote mean by NP which is equal to M. Then we are studied about definition of Poisson distribution. A random variable capital X is said to follow a Poisson distribution if its probability mass function, that is P dot M dot F, is given by P of x is equal to x is equal to e raised to minus m raised to x divided by x factorial, where x is equal to 0, 1, 2 up to infinity and the value of m greater than 0. And this Poisson distribution is denoted by capital X follows capital P of parameter m. Now we learn about properties of Poisson distribution. First one is the mean of Poisson distribution, which is equal to NP, which is equal to m. Then the variance of Poisson distribution, which is equal to also m, that is in Poisson distribution mean is equal to variance is equal to NP, which is equal to m, that is the value of mean is equal to the value of variance in Poisson distribution. Then standard deviation that is S dot D, which is equal to sigma, which is equal to under root variance, and here variance is our m. So we get standard deviation is under root m. Then additive property, the sum of independent Poisson random variables is also Poisson variable, that is for x and y are independent Poisson random variables with parameters m1 and m2, that is for Poisson random variable capital X their parameter is m1 and for the Poisson random variable capital Y their parameter is m2. Then x plus y, that is additive property, x plus y follows Poisson distribution with parameters m1 plus m2. Okay? Now there are some uses of Poisson distribution. First one is the number of due to disease such as heart attack, cancer, etc. The second example, the number of accidents during a week of month. Third, the number of phone calls received at a particular telephone exchange during a period of time. Then the number of defective articles in a lot. The number of cars passing a particular point in a road during a period of time. Then the number of printing mistakes on a page of a book. Okay? Now example number 1. The mean and variance of probability distribution is 5. That is here given that m is equal to 5, that is NP, which is equal to 5. It must be a Poisson, write down its distribution. Here already given that mean and variance of a probability distribution is 5, that is here mean is equal to variance. So, here we have Poisson distribution. Okay. Then m is equal to 5. Just a minute. That is, here Poisson distribution with mean m is equal to 5. P of x is equal to e raised to minus m raised to x divided by x factorial for x is equal to 0, 1, 2 up to 5, which is equal to e raised to minus m. What is the value of m? Here 5. So, here we get e raised to minus 5 m raised to, that is the value of m is 5. 5 raised to x divided by x factorial. This is our Poisson distribution for value x is equal to 0, 1, 2 up to dot dot dot. Okay. Now, we just a minute. Okay. Example number 2. In a Poisson distribution, the probability P of x for x is equal to 0 is 10% and find the mean of the distribution. Here we have to find out mean of the distribution, that is m. First we write down P of x is equal to 0, that is the value of x is 0, which is equal to 10%, that is 10 divided by 100, which is equal to 0.1. So, here we get P of 0 is equal to 0.1. Let mean of Poisson distribution is mean of Poisson distribution is m. Now, we write formula of Poisson distribution, that is P of x is equal to e raised to minus m raised to x divided by x factorial. Then for the value x is equal to 0, here we get P of 0 is equal to e raised to minus m raised to 0 divided by 0 factorial, which is equal to 0.1, that is here P of 0 is equal to 0.1, which implies e raised to minus m raised to 0, which is equal to 1 divided by 0 factorial, which is equal to also 1, which is equal to 0.1. So, here we get e raised to minus m is equal to 0.1. Then here we write 1 divided by e raised to plus m, which is equal to 1 divided by 10, which implies e raised to m is equal to 10. Now, we apply log on both sides. So, we get log e raised to m is equal to log 10, which implies here we use logarithmic rule. So, here we get m log e is equal to log 10, okay, log 10. M into the value of log e is 1 is equal to log 10, which implies m is equal to log 10 to the base e, log 10 to the base e, and the value of log 10 to the base e is 2.3026. Here we use logarithmic table, so we get the value of log 10 is 2.3026. So here we get final answer of m is equal to 2.3026. Okay, that is the mean of the distribution, that is m is equal to 2.3026. Okay. I hope all of you understood Poisson distribution, their formula, their uses and the respective two examples. In next lecture, we will learn more examples of Poisson distribution. Okay. Thank you.